Welcome to a talk called Ramping It Up, Deploying Real-Time Predictive Analytics in Healthcare. My name is Russ Clay. I'm a senior data scientist at the University of Virginia Medical Center. Just before we get started, a couple of quick things. Hopefully everybody can hear me okay. If you're having any trouble, please post to the chat or the Q&A. Looks like I can see both. And I'll get things taken care of. But thanks for everybody who's attending. Thanks to the TomTom Foundation for having me. What I wanted to do is give a quick talk about a system that we have developed at the University of Virginia called RAMP. It's our system for deploying predictive models in real time for our health system. And it's very much a work in progress. So I'm going to kind of talk about the journey that we've taken to get RAMP to where it is today. We still have a ways to go, and so I'll also talk about some of the challenges or kind of really important lessons learned that we've had along the way. And again, definitely interested in questions. If people have them, please feel free to post them in chats. I'll try to keep everything flowing and pretty good in real time and get those questions answered. As we get started, just wanted to recognize some core members of our team that's been essential in developing the system that we call RAMP. So it's a team of other data scientists, of clinicians, nurses, agile coaches, just a lot of people and a lot that aren't mentioned here as well, that have provided really valuable input into helping us grow a system that we think is really come a long way in helping us improve our patient care. So if I go back about 3.5 years to early to mid 2017, we had a goal in the University of Virginia Health System. We needed to reduce mortality. And so we had a couple of things that we wanted to do to try to accomplish this reduction in mortality. We needed to try to detect patients whose condition was deteriorating and detect them early. We had a lot of really sick patients in the University of Virginia Health System. And so one big challenge was differentiating between a patient who was deteriorating rapidly and a patient who was pretty chronically ill. And sometimes that's not the easiest thing to do if we're looking strictly at vital signs, lab results, things like that. And we needed some additional tools to help support our decision-making about our patients. So we felt the first two goals we could accomplish through some predictive risk modeling. And just in order to support clinical decision-making, we felt like we needed better visualization about who our patients were, where they were, what was happening to them at any given time. I'll talk a little bit more about why that was a challenge in a second. We also had a separate but related issue. Our hospital was getting more and more crowded. There was a lot of limited bed space. Our patient population was getting somewhat sicker on average. We had a real need to manage our bed flow, manage the patients that needed to get into the hospital and make sure that they had a place to be and that they were seen and taken care of well. Make sure that we also weren't pushing people out that needed to stay longer, but somehow make the best use of all the beds we had. So we wanted to improve efficiency in our admissions process and our transfer process, especially our outside transfers from other hospitals. We needed to really do what we could to make sure that staffing was appropriate given the mix of patients we had, particularly make sure that we had the right amount of nurses taking care of the right amount of patients given the patient's needs. And that we wanted to make sure ultimately that all of our patients were receiving the appropriate level of care. So again, first two questions we thought could be addressed well through data visualization. And we could also do a good job of hopefully addressing these with some predictive risk modeling as well. So there were some bumps in the road early on. When we looked strictly at our EMR and trying to do a lot of these things within the existing electronic medical record system that we had, if we wanted to talk specifically about predictive models, there are a lot of constraints on the types of models that we would be able to implement. mostly we could build scorecard models that are going to assign a point value to an input, whether that's a vital sign input, a lab measure input, that falls within a particular range. We would be able to assign a point value. That was kind of the most common model that we were able to implement. We had some ability to implement maybe some logistic regression models as well, but we had a lot of limited developer space with our EMR system. There was a lot of competition for the developers that we had. So even if we wanted to do some of those models, we were looking at probably months in order to get them implemented and operationalized. And we had a lot of constraints on the types of models that we were going to be able to build as well. And our EMRs really, and I think this is true of most EMRs, at least that I'm aware of, they're really built as a patient chart. They're built so that you can view one patient at a time. And what we needed in a lot of situations was the ability to see kind of what's going on with a whole unit or a whole floor at any given time, to know how to prioritize which patients that we needed to attend to immediately versus which patients were maybe doing well and didn't need to be seen right away. We needed to be able to see trend information on patients, where really our EMR is geared to showing you what's going on with the patient right now, what's their most current status. And it's not so easy to maybe see what's been going on over the course of the last 24 hours or so. We have other sources of data. We have a large data warehouse. That data warehouse only extracts from our EMR once an hour, so it really limited our ability to do anything in real time. We needed to build different models for different patient populations, which is not something our EMR was really geared towards. And we needed a strategy for testing, deploying, and revising models in really a rapid cycle time frame as well. So this is how the platform that we're calling RAMP kind of came to be. So RAMP stands for Real-Time Analytics and Monitoring Platform. What we do there, we have a Python-based application that connects in real time to our EMR system via REST API. And we have a separate model engine that we call the model engine. We're able to build predictive models that run in a system outside of our EMR. It's its own REST interface-based Java platform. And in this system, we can deploy whatever kind of models we want. We can build random forest models. We can build Bayesian networks. We can build neural networks. We can kind of decide how we want to create a model and implement it for real-time use. And as long as we can send the right data about a patient to the model engine, we get that data back and we can do what we want with it. But it eliminated a lot of our constraints in terms of the types of models we can build. And it also allowed us to build custom visualizations for different services and teams throughout the hospital. We can display these visualizations in different ways. Right now, what we do for the main areas of the hospital where we use this system, we have big touchscreen monitors installed on the units so that the nursing staff or the clinicians can just go up to the screen, kind of navigate through our list of patients. A lot of times we meet around those boards to have discussions about what the plan of care is going to be for a given unit or a given set of patients for the day. But this is a web-based service that we've built, so it's also available on users' desktops. If you're on the secure network, you can access it from mobile devices as well. So it's what we've tried to do is really be as flexible as possible and put visualizations for this system in the hands of the users that need it the most. So just some examples of what this looks like. So this is giving you a view of the third floor of our hospital, which is where our general medicine population is. This is the first floor of the hospital to use our RAMP system. And so what you see here is color-coded beds. So those beds are color-coded depending on the current model score for the patient that's in those beds. And we have a whole roster of models that we can select from. So we can pick and choose different models, and we can see a kind of color-coded aggregate view of our patient population at any given time. And I think this has been very helpful in in letting us kind of decide, okay, which patients do we want to be looking at any given time. So I apologize, just got the message up. It says that people can't see our screen. So let me see. How are we doing? Can somebody give me a message in the chat if we can see these now? Okay, my apologies about that. I thought I was sharing and the chat kind of disappeared for me for a little bit. So as I was saying, this is really kind of the first screen that had an example view of our what we're calling the RAMP platform. So hopefully, I'm glad I caught it there. So as I said, this is a view of the third floor of our hospital. It's giving color-coded beds for each patient in the hospital. This is not a real-time view, but just a screenshot. So we've also got we've got a roster of models that we can choose from. So if we want to deploy different predictive models for the same set of patients, we can have as many models here as we want, and we can pick and choose and kind of in real time transition from model to display what we want to see about any given set of patients. So right now, kind of what we use is we have a model called News Plus, which is a vital sign based early warning score model. It's giving us point totals that are based on standard temperature, blood pressure, pulse oximetry, supplemental oxygenation, things like that. We also use a SOFA model, which is more of an ICU level of care model that's giving us some point values based on things like lab results, red blood cell counts, things that are kind of more in tune for our ICU population, use of vasopressors. But kind of the main point here is that we can deploy any model that we want to develop on the system and just add it to our roster of models, and let that be something that kind of guides how we are thinking about our patients, how we want to prioritize patient care. What we also get is a lot of information about our current hospital census. So how full are our teams? Does this give us some help us prioritize how we're deploying our nurses? Does it let us call in extra staff if we're getting really, really busy? It's serving multiple purposes at the same time. It's letting us know how our patients are doing, and it's letting us know how full we are and how taxed our physician staff is. We have other views. So we have unit-based views that focus in on a smaller subset of patients, but also give us some trend information over time. So we can see, okay, maybe our patient has a really high model score now. How did they get there? Have they been at that high model score chronically for a long time, or are they really kind of creeping up? Did they start out doing well, and in the last 24 hours, have they gotten a lot worse? So that's been helpful to say, kind of, where are our patients? Is our patient at a moderately high score but stable, or are they really kind of on the way down and somebody that needs care immediately? We also have individual patient views as well, where we can look at the individual components that are driving a patient's score, how those have trended over the past 24 hours, and how that's contributing to their overall model score. And we can customize these views for our different models. So what we're seeing right now is our what we call our News Plus score. But we have different views for different scores, and some of them allow us to kind of go in and select different lab results or vital signs that we want to zero in on and see what's going on with a given patient. A little bit about how this works behind the scenes. So RAMP is a standalone application. Like I said, it's developed in Python. It uses a REST API to pull real-time data from our EMR. After we extract this data, we have another Java-based. It is a PMML, so an XML derived, what we call a model engine. So it takes, again, in REST format, we can send, as long as we send the right set of model inputs, it'll send us back a score and some component scores for the model as we define. We also have the ability to take those model scores that we get from our model engine and write them back to our EMR system as well. So we're doing that with one of our models right now. We have some asks to do that for a few other ones. But it allows us to have this kind of real-time component, a real-time application that's taking data from our EMR, processing it, putting some advanced analytics on it, and then if we want, writing it back into the patient's chart so that the doctors can use this as well. We maintain our own database behind the scenes for RAMP, and then we have a separate, again, Python Dash-based application that's running, that's accessible to any approved users that are within our hospital's secured network. So I have a question in there before I go much further. Can we explain a REST API? So our EMR vendor actually provides us with a host of web service calls. They give us a set of REST endpoints where if we provide a well-formatted and authenticated request to a given URL for our EML's web server, which generally means sending a web request with data about which patient we want information about, or which unit of the hospital we want information about. We get information back directly from the EMR about what we've got in real time. What is the most up-to-date information about a patient or about a unit? And so we use this in some different ways. We use it just to get the current census of a unit as well, So I can say, give me all of the patients that are on the third floor. So I'm basically passing it, the third floor units, and it sends me back the list of patients that are currently on the third floor. And then I can parse that list of patients and say, okay, for all these patients, I need their temperature, I need their respiratory rate, I need their blood pressure, and I want all those values for the last 24 hours. And it will send me those back as well. And then I can take those and send them to our model engine and get predictive model scores back from that curated set of vital signs. And so our EMR vendor gives us access to a lot of, not all of the information that's in the EMR at any given time, because the EMR is huge, but it gives us access to a lot of information real time about patients that lets us build some good predictive models. So hopefully, if there are other questions about what we mean about REST API, I'm happy to answer those. Maybe that's something that we can take into the virtual lounge for the networking after the talk. But essentially, when I say REST API, it's an interface that our EMR system provides for me to get real-time data about our hospital units and about the patients themselves at any given time through some Python applications that we can custom build. So the value that we've seen this add, it gives us more flexibility for our healthcare system because we can put together any type of predictive risk model. We can build scorecard models, which is what our EMR can already do, but we can also build regression models. We can build random forest models. We can build neural networks. That has come into play, and we've seen that be really valuable, expanding the types of models that we can build. Because really, when it comes to predictive models for deteriorating patients, we've seen that nonlinear models are really, really useful. Linear models themselves are not very useful because that's not really how patient data behaves. And so it's freed us up to implement lots of different kinds of nonlinear models that weren't really easy to do within the existing structure of our electronic medical record system. It allows us to pull information from a lot of different sources. So not only can we pull it from the EMR, we have access to our physiological monitoring data, which pulls data at a much higher rate. We sample several measurements per second when we have a patient hooked up to a physiological monitor. So it gives us data at a much higher resolution that we could deploy in predictive models. We can also pull from our data warehouse as well, which lets us go back and probably pull a lot more history about patients than we have in the past. So again, lots of different ways that this can be flexible. We also have a ton of flexibility around the types of visualizations that we can put together. If our users come to us and say, hey, I want to see information about a model, but I want to see it trended for each individual patient over a 36-hour period, and I want to see the model scores being broken down by every 2-point range, and I want to see them color-coded in a specific way. Like we really have the ability to do whatever our customers, our clinical customers, want to see with our models, which has been really, really helpful. And we have made a lot of changes in these first couple of years to the way that we present our visualizations. And I think that's because we've been able to deploy one visualization, get a lot of good feedback from our users, and then update and customize. And that's been really, really helpful. This has allowed us to be scalable. We can continue to develop models that suit our needs. We're not locked into whatever any vendor provides us. And we can do model development and customization at our pace. If we need to quickly iterate through a set of models and get something out faster, we can. If we want to run a test for 3 months and say, hey, let's run this test in the background, collect some data, see if it's identifying patients that really are in need of heightened care, we can do that. And so what we've seen with some data collection to this point is that when we deploy these models in real time, and we've really to this point been doing it in a passive way, we show these model scores, we display information about our patients, but we're not telling anybody necessarily to do anything. We're not prescribing any kind of alarms yet. We're starting to get into that. We're starting to test that right now, but we haven't rolled that out in a production way yet. But we still have seen that patients with higher model scores are getting increased interventions from nurses and doctors. We've just seen this be really useful in facilitating discussions around patients, especially in morning rounds with doctors. We'll huddle around these boards, these big touchscreen boards that we have on the floors, and doctors will say, okay, who do we want to talk about today? And we can dig into these visualizations that we've built and kind of get some group consensus about what's been going on with the patient, what needs to be done. And so we're watching to see in the long term, how does that impact our hospital mortality and our length of stay? During COVID, this was a useful tool to really help us kind of scale up how we were monitoring patients. So our hospital operations changed dramatically during COVID. We opened a completely new tower at our hospital, which hadn't been scheduled to open yet, but this was to accommodate and isolate our COVID population. And we did this kind of early March, April, thinking, hey, we might get a big influx of patients here, and we need a lot of beds in a place where we can really house these patients. Well, that shifted our patient care teams around a lot, and we were able to update and customize our ramp visualizations to reflect that in not real time, but close to real time. We were able to be agile and get in there and create new visualizations that displayed where we were hosting our patients. It also, because a lot of our non-clinical staff was working remotely, it gave them a way that they could still access a lot of aggregate real-time information about patients from their desktop. We had originally been just using RAMP on one floor, our general medicine floor. We quickly rolled this out to the whole hospital once COVID started. And we started running all of our early warning score models on on our entire adult population, so that it was available to our ICU docs in case they needed it. I know I've only got about a little over 5 minutes left, so I wanted to talk and focus the last part of the talk on what I think were the biggest lessons we've learned so far, and the things I would try to convey to anybody else that really wants to implement some sort of system like this. One, that we found that although we can put together some really complicated and complex models that potentially do a good job of pointing us at the patients that are at highest risk of deterioration or certain outcomes. Having an interpretable model is really, really essential for clinical buy-in. We can put together a lot of these black box models that might be really good at telling us which patients are at risk. But if we can't tell a clinician why a patient's at risk, why the model sees them as potentially at high risk for deterioration or at a high risk for a negative outcome, we're not going to really get that buy-in from clinicians. And even if we do, we're still not telling them what they need to focus on, what they need to do about that. And so we've kind of steered away from models like neural networks, random forest models. We'll use these a lot as kind of baselines to see how well we could be doing, but we've done a lot more kind of Bayesian type models which give us some conditional probabilities. If we have multiple sets of vital signs or lab values that are coming back at the same time, it gives us some conditional probabilities about the outcomes that we've seen in the past with those sets of values. That's been one really important lesson that we've learned in terms of model building. I would also say it's extremely important just to have clinicians as part of the team developing your models and helping you roll them out, because they're the ones that are going to get the buy-in of everybody else, the nursing staff, the other clinical staff that's going to use it. They're going to help people buy into these models once you roll them out. We've learned that we really need to make sure that we have objective baselines when we're evaluating the quality of our models. We try not to develop models that are based, that have a target that's based on past decision-making. We try to use objective measures, objective outcomes like mortality, rather than saying, let's develop a model that's going to predict ICU transfers and use our past ICU transfer judgment. Because our best model in that case would just replicate what we're already doing. We want something, some objective physiological state of the patient that we want to try to predict. And finally, don't let perfect be the enemy of good. We could build a great model, but if we just have one that helps us do better than we're currently doing, it's good. Let's get that out. Let's start using it, and then let's iterate and build on top of that. So I kind of rushed to the end there, but I wanted to make sure there were chances for a couple of questions if we've got them. Anything that I can talk about a little bit more, or anything that people have more questions about? Okay, I'll tell you what. So I know that I ran through things pretty quickly there at the end. I know there were a couple slides that weren't displaying at the beginning. I will definitely head over to the virtual lounge. Happy to kind of talk in more detail about any part of the process that we've walked through before. Any important lessons that we've learned along the way. Do's and don'ts about our model development process. Happy to chat at length about any of that stuff. But thank you again to everybody who joined. And thanks again to TomTom for having me as a speaker. I appreciate it.